Hey there, everybody. Welcome to the Smash News Network, least busted name in news. I'm your host, Dan, a.k.a. Smash-a-Mash, wishing a happy birthday to Mothra. Thanks for tuning into the meteorology segment. Here we go. Starting things out with the jet streams. Jet streams of the Western world look a bit like this. We're viewing the 250 hectopascal winds for the western side of the planet. A little incoherent in the southern hemisphere and a little bit chaotic in the north. Next, the surface winds. There are the surface winds and some strong winds there, southeast of Greenland, sort of in between Greenland and Iceland. Some very high waves there as well. We won't cover it in this video. Let's take a look at the surface winds of the east side. There are the east side's surface winds. And here are the jet streams of the east. Some divergences happening here in eastern Australia. Also a divergence happening here just west of the U.S. Strong jet there over the central Pacific, and some backward jet stream here over the equatorial Pacific region. Jet stream blowing east to west, which is also backwards. Next, the pressure and precipitation forecast here for the lower 48. That's a 72-hour GFS model precipitation and pressure forecast. Some additional snow coming to the Rockies in the next 3 days, likely. Places like Wyoming and Colorado especially. And let's continue on to look at snow depth. So there is snow depth. And check it out. We've got snow in Mexico here. Snow covering most of New Mexico at the moment. And let's take a look at sea ice. So were you aware that you're living in an ice age? An ice age is a time when the planet has persistent ice at both poles all year round. So I'm showing you one of the lowest ice totals that we saw here. Back in September 2008, we saw very low levels of ice. So of course, every year around September 1st, the end of August, the beginning of September, we see a dip in the amount of ice volume. So when we're looking at sea ice volume, it's not the area that it covers, it's the area plus the thickness included in the calculation there for sea ice thickness. And you can see this is all the way at the bottom of the list here. 2008 was a very low sea ice volume year. Since then, we've had various different years. However, there has been ice at the North Geographic Pole for the entire time. There's never been a point where there was no ice at the North Geographic Pole. So there were times when it shrunk, such as 2012. The ice got very low. Carbon dioxide continued to go up, though. And since then, we've seen some quite high ice years. So here you can see ice building early in the season quickly, and then big variations in the amount of ice. Whenever you see those red areas, that's 4 meters of ice. And when you see those turn to this whitish color, that's 5 meters of ice. So you can see some very thick ice there, tending to be around Greenland. And then you can see different years. I mean, you get different amounts of ice. The end of 2020 featured very low amounts of ice. You've only got about a meter of ice there around the geographic North Pole. But since then, ice has come back. So as you can see there, September 2021, there was more ice than September of 2020. And again, various different seasons here. I don't see a trend of diminishing ice. I see variations. So that's going all the way back to 2004. I'm just going to swing through this one more time. An ice age is a period in a planet's history when there is persistent ice at both poles through the summer. You're living in one. It's a warm period during an ice age. And I'll just leave it there. There's the current state of affairs. Quite a bit of ice there in Northern Hemisphere winter. Next, looking at our weather.gov map. Weather.gov, if your county is lit, Just head to the website, click your county. Looks like we've got some winter weather advisories here in Lehigh County, Pennsylvania, where we're located. Next to NASA GOES lightning mapper, and no terrestrial lightning here at the moment, maybe in Mexico, not in the U.S. So here's a real-time lightning mapper, courtesy of blitzortung.org. Lightningmaps.org is the site that we're using. Pretty calm conditions as far as lightning go at the moment. By the way, this video was originally streamed live to Twitch. You should check out the Twitch app. It will actually alert you when we go live, unlike some other apps on the internet that will remain unnamed. We're also on BitChute. Thanks to our subscribers over on BitChute. Make sure you watch our space weather videos. We've got all kinds of content and comments that are on YouTube and not on BitChute, so make sure you join us over there on YouTube. If you refuse to, I understand your reasoning. Thanks to our YouTube viewers for putting up with the pathetic censorship on the platform. We're hoping Google fixes its software. Indeed, we insist that they do so. We fixed ours at smashamash.com/SmashTeam, so consider supporting the channel by becoming a member of the Smash Team at the gold or silver level. And let's get back to meteorology. Here's the water vapor environment from a geosynchronous satellite over the Pacific West. So this is the GOES Pacific West water vapor satellite, showing you how moist the air is over Earth's largest body of water. It'll give you insight into weather moving into the western U.S. if you know what you're looking at. And we focus on these large views because we want people to understand atmospheric physics in order to forecast our own weather. Next, the full 50 states view here, U.S. Doppler radar. We'll focus on the lower 48. There's the current situation on the radar information, radar.weather.gov. Here's the shortwave radiation map, and I would note low clouds all over the Gulf and Atlantic Oceans. Look at all the low clouds there. You can clearly see low cloud, persistent low clouds. And next, the water vapor map. We'll bring it back and do a recap. That should give you some insight into how those precipitation systems are going to move. Here's your recap, starting with radar.weather.gov, the U.S. Doppler radar. We'll let it play through a second time. And some precipitation moving into Seattle once again. Here's a shortwave radiation map showing clouds and fog at nighttime when it's too dark to see them with a visible satellite. 3.9 nanometers is the wavelength, and here is the water vapor satellite. This will give you the most insight if your Doppler radar is not helping you understand what's going to happen next. For example, down here, we've got a bit of an impulse of dry mass of air helping to push this system through toward the northeast. That's about it. Thanks for tuning in to the meteorology segment. I've been your host, Dan, a.k.a. Smash-A-Mash, signing off from the Smash News Network. Least busted name in news.